Hey everyone, and welcome back to PrepFusion. So today we will start the lecture 9A of calculus chapter, which is from indefinite integration. So in this lecture we will mainly solve questions whatever I gave you as homework in the previous lecture. So this is basically a assignment solving lecture. So we studied about what does integration mean, what does indefinite integration mean. Okay, I told you the importance about this constant of integration. Okay, and yeah, next we learned a few formulas. So in the previous lecture I mentioned like this cot x is equals to minus log of sec f. That was here only. Cos x. I mentioned the formula wrong over there, so it may so happen we make errors. So like I forgot to write the formula down that time. So integration of cot x will be log of sin x, basically the opposite of tan x. Whatever the integration of tan x is, it will be the opposite of for cot x, and it will be minus log of cosec x. Okay, so this will be the integration of cot x, and we learned few formulas. Okay, I told you what substitutions you have to make for you to get to this result, right? These are the important substitutions that you have to make. So here I gave you more indefinite formulas, and I gave you a few things, right? That sin inverse of x plus cos inverse of x is equals to pi by 2 and all this, right? So you have to revise these things daily, else you will be forgetting it. I also am not able to remember everything. I write those down, and whenever I am near my exams, I try to revise them daily repetitively, right? So okay, so I gave you a few homeworks. I solved this first question, and I think I skipped the second question and the third question here, right? I skipped the second question and third question, so this will be the third question. So let's do this. So what I will prefer is I will solve the second question. I will give you the by yourself, do it by yourself, the third question. Okay, so obviously you have to do few things yourself, else you will not be able to solve in examination. That is very important. So what is the suitable variable that I can take common over here? So what I can do is that what I'm observing, I have x plus 1 over here. Now if I have x plus 1 at the numerator also, if I cancel this somehow, I will be able to get I will be able to easily solve this integration. What you can do, whenever you have something like this and you are not able to find any substitutions, what you do is you try to factorize everything, right? So either you use the long division method, or if you are in more good practice, then you can observe that if I write something like this, x cube minus 1 plus 1 and then x plus 1 dx, what I can observe, this can make a factor, and this, right, 1 upon x plus 1 I can easily integrate. Okay, this is integrable, so this will be x cube minus 1. So x cube minus 1, I can further break this down to x minus 1 x square plus x plus 1 divided by x plus 1, and I have a plus 1 upon, this is dx, and dx upon 1 plus x. Okay, so this simply will be my ln of x, ln of 1 plus x mod of 1 plus x, and this here what will happen. Okay, something I made some mistake. Okay, sorry, I made some mistake. So what I should do is I should write the x plus 1 with this, not the x minus 1. Sorry for that. So this will become plus, this will become minus, and this will also become minus. So now what I can write this as integration of x square minus x plus 1 dx minus this. What is integration of this? This is simply ln of mod of 1 plus x. You can simply substitute 1 plus x to t, and you can do that dt equals to dx, and you will be able to find that at the end you will get ln of mod of 1 plus x. And what is the integration of this? So this integration is pretty straightforward, right, as these are getting cancelled. So this will be simply x cube by 3 minus x square by 2 plus x minus, or like you can write the ln of x in the bottom, but I will state like ln of 1 by plus ln of 1 by 1 plus x, or minus ln of mod of 1 plus x. Both of them are same, plus c. So this will be my answer. So the homework is solve the third question, right? That is the homework for you. Okay, that will be just like I will give you a hint if you want to take a hint. what you can do, you have 2x plus 1 over here, so you have to find a factor which is 2x plus 1. So what you can do is that everything will be same, just the difference will be you have to multiply and divide by 8x cube. Okay, not 8x, but 8 by 8, because this will give me 2x cube at the numerator, sorry, at the 8x cube at the numerator, and 8 this I can write as 2x whole cube. So yeah, that will then I will be able to factorize it. So yeah, that's the trick for this. Just multiply divided by 8. And also here I told you that you have to for this question, right, for this question you have to substitute the value of this sin x cos x, right, with this angle formula. So like trigonometries are very important, that those also you need to write and you need to remember those. So what you can do, I know that sin x cos x equals to sin 2x upon 2. So what I can do, I can write this as sin x cos x whole square, and then I can write this, right, sin square 2x by 4. So this I can write sin square 2x by 4, right? Or what you could have done is you could have divided and multiplied by 4, and 4 sin square x cos square x will be simply equals to sin 2x. That also you can do, dx. And now what you need to do, you need to use another formula. What is another formula? Your cos x minus sin square x, I'm writing in shortcut, will be equals to cos 2 theta. So I have sin square 2 theta, right? So what I can do, I can write this in terms of anything. I have sin square x, so I will write 1 minus sin square 1 minus 2 sin square x equals to cos 2 theta. So sin square x equals to cos 2 theta 1 minus divided by 2. Now the interesting fact over here is, so this is sin square 2x, so this will be 4 theta. So here I can write theta x, whatever you want to write, I'm just writing. So this will be 1 minus sin square 2x, so this will be cos 4x divided by 2, and also I have a 4 over here into dx. Okay, so now you can integrate. This is very easy to integrate. So what will this become? So this will become integration of 1 by 8. So what is the integration of 1 by 8? Simply x by 8. And integration of cos 4x, it will be sin x, sin x minus minus sign is there, so it will be minus sin 4x divided by 4 also will be there. So 8 into 4 is 32, plus obviously you can't forget the constant of integration, you have to remember that. So yeah, this will be my answer to this question. So then we learned about different methods of integration. First one, the most used one, is substitution, then by parts, then partial fractions. I gave you a few like basic examples, and then I gave you this question, right? I gave you this question as homework. So let's do this. So like the most blatant thing is they will give you what you need to substitute. So basically this, right, this power is seemingly very difficult for me to substitute, as is an exponential raised to the power something. So what I can do, I can name this variable as t. So you name this variable x minus 1 by xt, and like you will observe that magically everything is happening. So if you write dt equals to 1 minus, and this will be 1 plus x square dx. So now what will happen? Now basically what I can do is that this will become, now this multiplied with dx, this multiplied with dx equals to simply dt. So I replace this with dt, and now this e raised to power t. So t, this is t, right? This is equals to t. So this will be e raised to power . So like the integration of e raised to power t is simply e raised to power t plus c. So now I can replace t as 1 plus 1 by x square. Obviously don't forget to replace not 1 plus 1 by x square, x minus 1 by x. Don't forget to replace your previous variable, that is very important, plus c. Okay, so like this is also another type of problem. So what you can do here, this denominator is a problem. So what I can do, I can directly substitute this denominator. So I can write a plus bx equals to t. So my dt will be equals to simply b into dx. So then what I can do is that I can write few things, that my dx is equals to yeah, just hold on a second. So my dx is equals to what? Dx is equals to dt by b. So I can write over here, what is x? X equals to t minus t minus a divided by b. This is my x, because if I am replacing everything from x to t, I'm going to t. So for in case of this, we have studied this indefinite integration. When we will study this definite integration, then what will happen is that whatever we are like using here, right, the limit does not exist. Like at the starting I told you that limit does not exist here, like there are no limits, indefinite limit exists. So we have to, whenever we are using this method of substitution, we have to take care of the limits as well. So it is very important to take care of the limits. So this will be simply x square. So this will be t minus a by b whole square divided by t square into dt by b. So this b square is there, I can take common b cube. This is I can take the t square inside, so this will be 1 minus a by t whole square, okay, times dt. That I can simply integrate. So what you can square this, right? You can square this out. So this one will be 1 by b cube 1 minus, like you try to use as like you try to write as elegantly as possible, try to write as less things as possible. Here what did I do? I just took this t square, right, inside this bracket thing. So both of them are square, I can just take this t square inside, so this will become just t inside this whole bracket, whole square. So t by t is 1 minus a by t. Okay, that is what I have wrote over here, to write as less things as possible. This is minus 2at minus 2a by t, and this is plus a square by t square. One by b cube integration of t minus 2a plus a square. Oh, this will be minus also, because there will be minus 2 get minus 2 will get multiplied by t cube plus c. So yeah, this will be, am I correct? Okay, I have, oh sorry, I made a blatant mistake over here. So this, right, this will be simply t square minus 2t. So this will be ln of t, right, because I have a ln over here also. Yeah, so basically I can replace my t like this. T is equals to a plus bx minus 2a ln a plus bx minus 2a square divide by this a plus, okay, I made a mistake again over, this will n plus 1, right? This will be only t, sorry, I'm just out of my mind right now. Okay, sorry for that. So this will n plus 1 into 1. So yeah, sometimes we also tend to forget the formulas, right? This happens with us. So yeah, this will be simply a square by t, because what is the formula? Formula is simply n plus 1 into t raised to power n plus 1, right? Sorry, n plus 1 will get divided. That was for differentiation. So this is the formula. So yeah, that is what I am doing. So this will be simply a by t, which is a plus bx. Okay, this will be my answer. So there was, I think there was a, okay, now this was the only question. Yeah. So I told you about the angle formulas, right? How if I have a square minus x square plus a square, what substitutions you have to make. These are the few standard substitutions. So yeah, let's solve few things. So I gave you this one, was the first one. Okay, this one was the first one. So you get this direct result. So either you can derive, what you can do is that you can write here that your x is, okay, I can come back to the formula, x square plus a square, right? X is equals to this a tan theta, right? If you write this, you will be able to get to a result. So I won't derive here, or I will write those down, write the derivation down just for your intuition, nothing else. So here also, this I also told you to put this in things in the short notes. Okay, this also I won't derive right now. I will just write this down, and like you can understand the derivations, right? All those things. So yeah, this one was it, and I solved this question, right? I solved this question using simple substitution and like the tan inverse formula. That is very important formula. Then we started integration by parts. So then I like gave you like what is the formula for integration by parts, how does it come. Then I like solved a question, and then I give you this homework, right? This is a type 2 of integration by parts. So in type 2, generally what happens, you don't know what to take for that integration function. You don't know, but always there is a 1 over here, right, with it. So what you can do, like you are like in the formula, in the integration by parts, we have this priority wise shortcut, right? ILET. So in ILET, exponential logarithm, this function comes at the last. Okay, so like that means that those I have to take as derivative. So those I have to take the derivative, but the problem is then what I will take as integration, because I have only one function over here. So if I have only one function, how I can write this? I can write it like this. So this will be 1 ln of x. So now if I have 1 ln of x, so what I can do, I can take this function and integrate wherever integration comes up, and I can differentiate this function. Okay, so now what I can do is that obviously I'm integrating this, so this ln x will be outside because I don't know the integration of ln x. That is the main thing, right? I don't know the integration of ln x, so I want to get to the answer. So obviously ln x I can't integrate, so I have to think about something else that I can integrate. In this particular function, 1 is present, so I can integrate 1. So this will be simply dx minus, again I will differentiate ln x, which will be 1 by x. Now integration of dx is into x. I will just write into x. Obviously we have a dx outside, obviously we have a plus c outside. So integration of this will be ln of x minus, this is integration of dx only because x and x gets cancelled very beautifully. So this will be minus x and plus c, obviously. So this is my answer to this. And whenever these type of questions come up, you try to solve it like this, that you don't know which function to take, so that I can integrate that function, right, in by parts rule. So obviously you have to use this method. So you just take the 1 as the thing, but here like what is the beautiful thing, that this x and 1 by x is getting cancelled. Like we have already learned one shortcut, that shortcut is the best, and you should use that shortcut only, that di method. So this is type 3 problem where I have e to the power 2x. Okay, and then like these are few important formulas, don't need to remember. I will just just use a shortcut and that is enough. This is also like just to give you a brief idea and intuition that yeah, if you can identify this format, that's good. If you can't, obviously you have to solve, right? So I also cannot remember everything. Just try to solve everything. That is the best thing. Just try to solve with practice. You need to gain more practice. So here, like I gave you this as homework. So any format are you observing over here? Any format you are observing? So what I can say is that this, right? Just hold on a second. So if I have e raised to power x, I have e raised to power x over here, I have x over here. So I can write this e raised to power x by 1 plus x whole square dx. Okay, so next what I can do, next like I'm observing again, I can do that thing because I can do plus minus 1. With practice you will understand when you will do plus minus 1 and when you will not do plus minus 1. That will save you time. So e raised to power x is plus minus 1, so 1 plus x divided by 1 plus x whole square and minus 1 dx. So this will become, I can take some different color. This will become simply e raised to power x 1 by 1 plus x minus 1 by dx. Okay, so this will be equals to so now what you can observe is we have got our format. So this e raised to power x 1 by 1 plus x, you can observe that this is in some this format, right? So this is f of x, and if I differentiate this, you will get this. So what will the answer to this? Simply this. Okay, either you can use that thing, right? So if you differentiate this is a product rule, you will get back to this. Okay, this is a type 4 thing. So what you can do, you can use a that substitution as well, that you are substituting your f of x. So yeah, you can simply do that if you write your t equals to 1 by 1 plus not 1 by e raised to power x by 1 plus x. So what you can do, what will be dt? Dt will be simply 1 plus x whole square, and the differentiation of this is 1 plus x, this is 1 plus x minus simply the differentiation of this is 1 only, this will be e raised to power x. So again, if I take common e raised to power x, I will get this 1 by 1 plus x minus 1 by 1 plus x whole square, and this is dt, and this is dx. Okay, so yeah, this will be this. So basically yeah, so you can observe, right, this is directly equals to dt. So what I can do, I can replace this with dt only. So I can replace this with dt. Let me write this as I. So my dt will become t plus c, and what is my t? T is simply e raised to power x by 1 plus x. Okay, it is basically f of x into e raised to power x. So this is how you solve this types of question. Okay, and then like I told you, the DI method. So you can use the DI method always. There isn't like any particular type of integration where you have to use a DI method. You can use it always. I'll say you can use it always. Okay, so I told you how to use the DM method on this question, so I gave you the next question as homework. So again, what can you choose as the differentiation here, like the what function you have to differentiate? So obviously you will choose this, because at the end this will go to 0 sometime, so you have to choose that function as the D function, or the function that you will differentiate, as that will go to 0, and if it goes to 0, then only you will be able to stop your DI method. This can also be used in some other cases. I will show you that method, like that, those recurring ones, in some other day. Okay, so here obviously this will be your D and this will be your I. Okay, so basically my D and I is this. Okay, so obviously you write x square over here and you write sine 2x over here. Now you slowly differentiate, so this will become 2x, this will become, if I integrate this, cos 2x by 2, and also there will be some minus sign with it. Next, let me put this stop. This will be 2, this will be now the integration of cos 2x will be simply sine 2x upon 4, also minus sign is over here. Then I will differentiate, this will be 0, again the integration of the sine 2x will be plus cos 2x upon 8. Okay, and after this 0, anyways this will get multiplied to something 0, and we will proceed further over here, right? Yeah, so the next step, what we do, we write the signs. First one is plus, then minus, anyway 0, it doesn't matter. So now we'll write the shortcut. So my integration I will be equals to simply minus of x square cos 2x by 2, and this one will become plus of 2 times like x sine 2x by 2, and this one becomes plus cos 2x by 4. Okay, so yeah, basically this will be your answer. Then I gave you this integration by partial fractions. So here, like it gave you, like this is just a simple method. Whenever you are given rational terms and whenever the power of this denominator is more than the numerator, obviously you will use partial fractions, okay, to simplify your equation. So here I gave you one hint previously that you have to use method of substitution and as well as this partial fractions. Like most of the indefinite integration questions, it will be a combination of two methods. Okay, so here first what you do, you observe that you have cos x dx, and in the denominator you have sin x. So what you can do, you can use the method of substitution, that you can replace t with sin x. Then if you take the derivative, dt equals to cos x dx. Okay, so dt equals to cos x dx. So simply to the integration of, I can say cos x is simply so this is simply equals to dt divided by 1 plus t and 2 plus t. So this will be equals to I can use the partial fractions. So what I can do, like you can directly observe this, or if you can't, then obviously you have to use that AV formula. So I can cover this one up, okay, and put t equals to minus 1. So if I put t equals to minus 1, this is 2 minus 1, 1. So this will be simply 1 by 1 plus t. Okay, then I can cover this one up whenever I calculating the residue. So this we will understand in complex variables. So we're calculating the residue for this simply using the partial fractions only, just with a shortcut. So I'm covering this one up and I'm putting t equals to -2 wherever this was going to 0. So if I put t equals to -2, this will be -1. So this will be -1 by 2 plus t. So basically just using the shortcut. Okay, nothing else, just using the shortcut. So this one will become ln of 1 plus t minus ln of mod of 2 plus t. Don't get confused with t and this. So plus c of course. So I can further write this ln of mod of 1 plus t. 1 plus t means 1 plus sin x divided by 2 plus sin x. Plus c. Okay, so yeah, this will be the answer to this question. So you can cross verify. Now I was talking about some other cases where I have non-repeated single poles. So you can again factorize this, right? You can again factorize this. So you can further write this down, that x square plus 1x into x minus 1 into x plus 1 equals to my a. I can write this in summation of 3 factors. So a plus a by x, b by x minus 1 plus c by x plus 1. Okay, so now if I cross multiply this x into x minus 1 into x plus 1, I will get x square plus 1 equals to, this will be remained with x minus 1 into x plus 1, which is x square minus 1. Then this will have x into x plus 1, and also this will also have x into x minus 1. Okay, so what I can do is that I can equate the constant terms and the this coefficient of x square. Before that, I can put x equals to 1. If I put x equals to 1, this one will go to 0, this one will go to 0, this one will remain. 1 into 2 equals to 2 itself. So here b is equals to 1 at x equals to 1, b is equals to 1 at x equals to -1. If I put, this one will go to 0, this one will go to 0, but this one will still remain. This is -1 times -2. So this is -2 and this is +2. So here I will get -1. C is equals to -1. And what about a? I can simply equate the coefficients. If I equate the coefficient, ax square plus bx square plus cx square. So a plus b plus c should be equals to 1. I can write here. These methods I hope you already know. I am not like teaching you partial fractions right now. I hope you know. If you don't know, you can watch my video for control systems. Okay, I don't have time to teach the partial fractions thing. So equating the coefficients of x square a equals to, basically what I can write, this 1 on the left hand side I have 1, then a plus b plus c. So b plus c is 0 because -1 and +1. So a will be equals to, again, equals to 1. Okay, so a will be equals to 1. So now what you can do, you can simply replace this equation and you can replace this with simple logs. So this integration I can simply write it like this, that this is equals to a upon x plus b upon x plus x, what was it, x minus 1. So 1 upon x minus 1 plus c, which is minus 1 upon x plus 1 into dx. So yeah, what is the integration? The integration is ln of x plus ln of x minus 1 minus ln of x plus 1 plus c. So this will be simply ln of, I can write this mod of x into mod of, okay, I can write this like this also, mod of x into, okay, am I doing, yeah, sorry, I just observed that I may have made a mistake over here, that this I forgot, like that's why you tend to write, if you tend to like make silly mistakes, right? At first when you're doing calculations, you try to write everything without doing mind calculations. So if you tend to forget everything, you just try to write down over here. So what you can write, like minus 1 into minus 1, minus 1 into minus 2 is plus 2, and this is also plus 2, so this c will be plus 1, sorry for that. Now this c is plus 1, so this overall thing will be plus 2, and this goes on this side, so a will be minus 1, a will be minus 1, so this will be minus 1 over x, this is minus, so this will go to the bottom one, and this mod of x minus 1 into mod of x plus 1 divided by mod of x plus c. Okay, okay, so this is my answer to this question. So yeah, sorry for that mistake. So again, when I have repeated poles, so when you have repeated poles, what you can do is that you can write it in terms of this. You can write this down, that my 3x plus 1 divided by x minus 2, just hold on a second, let me write this better, x minus 2 whole square x plus 2 equals to what? Equals simply a by x minus 2, x plus 2 I can write, then you choose your coefficient b1, which is x minus 2 whole square, then you choose another coefficient which is like b only, b2, this power will be x minus 2. So you try to go from the highest power to lowest power, okay, cover all the powers. Highest power to low powers. So obviously you can write over here that your 3x plus 1 equals to a into x minus 2 whole square, because I'm multiplying x minus 2 whole square into x plus 2 on both sides. So plus this will be b1 into x plus 2, and this will be c1, not c1, b2 into x minus 2 and x plus 2. Now if I put x equals to minus 2, so this will go to 0, this will go to 0, and this will remain. This will be a into minus 4 whole square equals to minus 2, so minus 6 and plus 1, so this is minus 5. So a will be equals to minus 5 by 16. So this is what my a will be equals to. So let's put x equals to plus 2, hence this and this will get cancelled, so I will be left with only this b1 term. So b1 into 4 equals to 7, so b1 equals to 4 by 7. Okay, so now let's solve for b2. So how will we solve for b2? So what you can do, you can equate the coefficients of x square. So this has only one x square term, so b2, and this has no x square term, and this has one x square term, and on here we don't have any x square term. So equating coefficients of x square. So what you can do is that, so basically this will be 0, this is equals to a plus b1, a plus b2. So my b2 will be equals to minus of a, so a is equals to 5 by 6, so b2 will be equals to plus 5 by, sorry, not 5 by 6, 5 by 16, so b2 will be equals to 5 by 16. So I can convert this integration into this simple format. This will be simply equals to a by x plus 2. So a is what? 5 by 16. So I can write 5 by 16 by x plus 2, and b, and what is b1? b1 is 4 by 17. This is minus plus 4, not 4 by 17, 4 by sorry, this is, I'm wrong, this will be 7 by 4, right? 7 by 4 divided by x minus 2 whole square, x minus 2 whole square. Then I had b2 also, if I can cramp in enough space, which is plus of 5 by 16 divided by x minus 2 into, yeah, x minus 2 only, and we had this whole thing multiplied by dx also. So now if we integrate this, this one will become minus 5 by 16 ln of x plus 2 plus 7 by 4, and plus 1 is minus 1, so this minus 1 will get multiplied, divide by x minus 2 plus 5 by 16 ln of x minus 2. So this is plus c, okay. So this will be the answer to my question. So yeah, this is a very good question. You can club these logs together. So what you can write, here 5 by 16 into ln of x minus 2 divided by x plus 2 mod, and you can write this minus 7 by 4 into x minus 2 plus c. Okay, you can write like this. So you can club these things too. And in the last lecture I gave you how to solve using, I told you how to solve using the complex, like for a complex pools, how to solve those things. And if the degree is higher also, we solve for, like in one question we solve for two cases. If the degree is higher, obviously you have to use a long division method. And you can write the in terms of summation of two things. Okay, here I've written this in terms of summation of two things. And for complex pole we have to equate the coefficients carefully. Equate the coefficients like this. If I have complex pole, I am not able to break this down into real factors. So that is what we learned. And then I give you again few trigonometric integrations. So if I have something like this, a cos square x plus b sin square x, how to solve this. So I give you this. So like this one I will do. So what you do, you try to convert everything into tan, right? Tan. So here if I want to divide, so I will divide by cos square x on both numerator and denominator. So this will become 1 by cos square x divided by 9 by tan square x plus 16 into dx. So this will be sec square x. So this is sec square x, this is sec square x dx divided by Also what I can do, I can take this 9 common outside. So yeah, if I take this common 9 outside, this is tan square x plus 4 by 3 whole square. So this one will be 1 by 9 now. What I can do, I can use a substitution. So basically I can write that my t is equals to tan x. So dt will be simply sec square x dx. So what you can do, like, you might feel overwhelmed by all this. When you will practice, right, this may seem easier, and it's okay if you tend to forget these formulas. It's fine. Just try to write this down in some copies and try to revise those daily and try to solve few questions daily, and that's enough. Okay, don't worry if you are thinking that this is so much stuff and I have to remember. Don't worry, you don't remember all these things. Just try to do these problems every day and don't just lose your track. So whenever you're in the preparation phase, forget, you shouldn't go out for dinner or something. I mean, you can go out a day, but don't take too long breaks. Okay, take breaks for 1 day, 2 day, that's fine, but don't take long breaks, because if you lose that momentum and continuity, then it will be again difficult to go back to that same momentum. So whenever you are in that momentum, right, whenever you're in that zone, you try to continue to stay in that zone. That is very important. So I was also doing the same. So here what I can do, I can replace this like this, 1 by 9, this will be dt, just hold on a second, this will be dt divided by t square plus 4 by 3 square. Now do you remember any formula? This is formula of tan inverse x by a, 1 over a into tan inverse x by a. So yeah, this will be 1 by 9 into x by a, no, 1 by a, so this will be 1 by 4 by 3 into tan inverse x by a. So in our case, x is t by 4 by 3. Okay, so plus c. So now obviously you can replace few things. So this will be simply 1 by 12. Okay, x by a, yeah, this is fine. So this 4 by 3 will be outside, 9 is common. Sure, 1 by 12 and tan inverse (3 by 4) into tan x plus c. So this will be my answer to this question. Okay, so like next again I gave you few identities. Like whenever you have no power, single linear terms, then what you do, again you divide by, like, make this conversion, right, this power terms, and then you simply solve this. So what you can do, you can directly convert. Okay, you don't have to write tan x every time, tan x by 2. So this will be 2 plus, what is this, 2 tan like this form, right, 2 tan x by 2 into 1 plus tan square x by 2. So this will be 2t by 1 plus t square and plus minus t square by 1 plus t square, and I have dx over here because I haven't replaced any variable, just it is understood that t is equals to tan x by 2. So now what I can do, I can write it like this, that this simple thing is equals to 1 minus t whole square, right? Or like I can put everything together, club everything together. So 1 plus t square will be here, and this will be 1 plus t square. So this is 2 plus 2t square plus 2t plus 1 minus t square plus dt. And no, 1 plus t square divided by, so this is 2t plus 1, so 3 plus 2t, and then this is plus t square, right, into dt. So at this point, what we can do is that we can write this in terms of square, like summation of, like a square formula. So what you can do, this 1 plus t square, what is this 1 plus t square? This 1 plus t square, you can simply write it like this. So just hold on a second. This will be simply sec square x by 2, because 1 plus tan square x by 2 is sec square x by 2. Okay, sorry, this is not dt, I'm sorry, this is dx only, I forgot, I wrote a dt by mistake, sorry. This will be dx divided by now I can write this as summation of squares. So what I can write, this will be, here I have 2t, so if I can add plus 1 and minus 1, this plus 1 will be t plus 1 whole square, and this minus 1 will go to here, this is 2. So I can write it like this, t plus 1 whole square plus under root 2 whole square, because this extra 1 is getting added with this to make this whole formula square formula. So now what I can do is, obviously this t, right, t is equals to tan x by 2, so dt will be equals to sec square x by 2 into 1 by 2 into dx. So this will be simply dt, also a 2 will get multiplied because I just have sec square x by 2 into dx, I don't have a extra 2, so 2 will get multiplied. So this will be now this, right, I can write this as t plus 1 whole square plus under root 2 whole square. So what we can do next is that I can, like, you can directly solve this, or if you don't want to, you can take another variable s, which is equals to t plus 1. So ds will be simply equals to dt. So basically you can write integration of 2 ds divided by s square plus under root 2 whole square. Okay, only the limits will be changed, that we'll understand in the indefinite integration chapter. So obviously this will like, you can directly go to the step without even doing that substitution. So this will be 2 tan inverse of x by a, right? So this will be 2 tan inverse of 1 over a under root 2 tan inverse of s by under root 2 plus c. So you can directly replace this is under root 2 only, under root 2 tan inverse, what is s is equals to t plus 1, and what is t is equals to tan x by 2. So it will be tan x by 2 plus 1 divided by under root 2 plus c. Okay, so yeah, this will be your answer to this question. So this one was a pretty difficult question, and don't worry, I'm just solving few difficult questions so that you can understand like how to solve this indefinite integrals, and bit parts of this will be used in next topic, right? Next topic. So that's why it was very important. Just try to solve few questions, just try to stay in practice, and that's enough. Okay, so yeah, that's it for this lecture. I hope you like this lecture, and in the next lecture we'll start with a new topic, that is indefinite integration.